This is the color scheme that I use for my videos. Make sure you copy down the black.
The graph of the line in the xy plane has a slope of 2 and contains the point 1, 8. The graph of the second line passes through the points 1, 2, and 2, 1. If the two lines intersect at the point AB, what is the value of AB? Well, you can do this completely algebraically with all equations if you want, and that would be fine. So you have the point-slope form, which you should have memorized, and then you plug in the point 8 here with a slope of 2, 1, 8 with a slope of 2. When you simplify all that down, you eventually get y equals 2x plus 6. For the second line, you could have a slope of, taking the 2 points, it's 1 minus 2 over 2 minus 1 to get negative 1. And so once you have a slope, then you can use point-slope form with one of the points. So let's just take the first one. The first point is 1, 2. So you have 1, 2, and a slope of negative 1 that we just calculated. Then simplify, and you get y equals negative x plus 3. So if you know these two equations, y equals 2x plus 6 and y equals negative x plus 3, you can set them equal to each other. I mean, you have two different expressions for y, so you might as well set them equal to each other and see what happens. You get, this is solving by substitution. You get 2x plus 6 equals negative x plus 3, and then adding x to both sides and subtracting 6, you get 3x equals negative 3. Dividing the equation by 3, you get x equals negative 1. Plug that back into the original, you get 4. So the point A comma B would be negative 1 comma 4, which you can see right here, it's negative 1 comma 4. When you add those, negative 1 plus 4, you get 3. There's an alternate method, and here it is. You could actually draw out the graph if you wanted to. You have to be really precise, and that's difficult to do with pencil and paper. But if you were precise track of these points, you could graph them, and you could work your way back down to the intersection point. You could work your way up here to the intersection point. And you could get negative 1 comma 4. That would be tricky to do. You'd have to be kind of an architect in your precision, pencil and paper, be drawing very, very accurately, but you could get the answer that way. There's another alternative. Knowing that these 2 points add up to 3 is one way of creating the equation x plus y equals 3. Similarly, if x equals 0, so you could somehow get this equation y equals negative x plus 3. So here, y equals negative x plus 3, you get that, and then you rearrange it, and you get x. And that's actually true for these 2 points. This plus this is 3, and this plus this is 3. And in fact, it's true for all the points on this line, including the intersection point. You don't even need to mess with this equation at all if you realize that this red line is the line of all points whose x coordinate and y coordinate add up to 3. So what is a plus 3? Well, you don't even need to know which point it is. If it's on this red line, which this intersection point is, then it's got to add up to 3, which is the shortest, I think, way to do it.